Okay, hello everyone. Today I'll be talking about different types of RAID. And RAID means redundancy array independent drives, or it could also mean redundancy array of inexpensive drives. So, what it is a type of virtualization which enables you to configure drives into one or more logical units, and so that you could have better performance, or you could have redundancy, which means you could safeguard your data. So that's what it means. So in the first diagram on the left, you have RAID 0. So RAID 0, what RAID 0 does is you'll need two hard drives, but you're you'll be combining them as one basically. So you could essentially double the performance. You could increase the performance of the drive and increase the volume of the drive. So if you had two 4 terabyte hard drives, then you would have, if you had two 4 terabyte hard drives, you would have 8 terabytes of space, and the performance of the drives would be kind of like combined, so you would have better performance. However, the problem with this setup is that it doesn't have any redundancy. So if one drive fails, then all your data is lost, because like I said, there's no redundancy. So A1, A2, A3, A4, see, it's if let's say this drive fails, then A1 would be gone, all the odd numbers would be gone, so your data is um, is pretty much gone forever. So that's what it is. So it's pretty useless unless you want to have better performance or something. So that's a bad thing about it. But the good thing is you can increase the performance. Let's go to RAID 1. So what RAID 1 does, what you need for RAID 1 is you need two hard drives which are identical. The same with RAID 0, you need two hard drives that are identical. However, in RAID 1, you're not going to be doubling the space. So if you have two 4 terabyte hard drives, you would only have 4 terabytes of space, because what it's doing is it's mirroring the information on this drive to the other. So it's copying all the information from this hard drive to that hard drive. So if this hard drive fails, you still have all your information, and the NAS server or whatever, the server that you're using, will tell you that one of the hard drives failed. So you would just replace our hard drive and put a new one, and it would just takes a little bit of time for it to copy everything from here to there basically. So if one hard drive fails, your information is still saved. So there is redundancy here. So the next one I'll be talking about is RAID 1.0. So this is a combination of RAID 1 and RAID 0. So as you can see, this is RAID 0, which I showed you earlier. So this is RAID 1, RAID 1. So RAID 1 would provide the redundancy, and RAID 0 would provided you with the performance, increased performance. So as you can see here, we're using 4 hard drives here. So I have one set of RAID 1 and another set of RAID 1. So basically, in this setup right here, basically in one setup, if this fails, if this drive fails, your data is all saved, is pretty much saved, and then you could add another hard drive here to fill all the data from here to there. And if this set fails, one hard drive fails, your data is also saved. So one hard drive can fail from each RAID 1, and you would still have all your information basically. So RAID set 1 has the odd numbers, so like 1, 3, 5, 7, 9. RAID 1 set 2 has the even numbers. So basically, let's say I had four terabyte hard drives, right? The sum of all the 4 hard drives would be 16 terabytes. However, we cannot use all 16 terabytes of space. You can only use 8 terabytes if you had a sum of 16 terabytes, because as you can see, there's redundancy here, and on the next set you also have redundancy. That's why you cannot use all 16 terabytes of space. So like I said before, one set of hard drives can fail on each set, and it would be okay. So let's say if this hard drive failed and this hard drive failed, your information is saved and you don't have a problem. It has redundancy and it also has performance. So this is a good thing about RAID 1.0. It also has kind of like a mirroring as well, as you can see with the redundancy, which RAID 1 has, and you also have the performance of combining 2 hard drives as well into one. So the next one, we're talking about RAID 5. So RAID 5 uses something called Parity, which you can see right here. And you need at least 3 hard drives to use RAID 5. So it has parity. So what parity is it's let's say I have 5 hard drives. So the data from E1 E's is saved in parity E right here. Parity D, parity C, parity B, parity A. So as you can see, this is A, A2, A3, A4, and we got parity. So for RAID 5, one hard drive could fail, and you will not lose any data because you got parity, right? So let's say the first hard drive failed. Your data is pretty much all saved. But if you lose 2, then you got a problem. Then you will lose some data if you lose 2 hard drives. That's the bad thing about RAID 5. So let's say each hard drive here had about 4 terabytes of space each, right? So that would be 20 terabytes, right? However, 4 terabytes is used for parity, as you can see. So you have 5 units here. So each unit is 1/5 of 4 terabytes. So if you add 5/5 of it, then it would be 4 terabytes. So it's being used for parity. So like I said, if 2 hard drives fail, you lose information. But if one hard drive fails, your data is still good, but it's going to take a little bit of time for it to put all the data into that hard drive. So the next one I'll be talking about is RAID 6. So here, for RAID 6, you need at least 4 hard drives because the parity takes up about 50% of the space. for each hard drive. So 2 hard drives can fail, and you could have all your information will still be saved. And this is a very secure setup. It has a lot of redundancy, which is good, which means your data is more secure. However, it is about 20% slower. So if you had 4 terabyte hard drives, if you had four terabyte hard drives here, that would be about 4 times 4, that's 16 terabytes, right? So then you would only have 8 terabytes of space. So half, basically. Because half of the data is being used for parity, as you can see. So we got 2, 3, 4, 5, 6, 7, 8. 8 terabytes, and we also have 1, 2, 3, 4, 5, 6, 7, 8 terabytes, which is being used for parity or type or redundancy. So this is a very safe configuration. So basically, if you're using something like a NAS server, you would have to know what the different type of RAID configurations are, so you could so you could use it more efficiently. So you would know what you're doing. So you would know how many hard drives you would have to have and stuff like that, and what it's doing, and the configuration that you want to secure your data, basically. And that's it. So thanks for watching my Ace 1000KS 1975 signing out.